This is Mr. Beck Does Your Homework. This is Physics Homework 16, question number 4. A 0.2 kilogram bead slides on a curved wire starting from rest at point A, as shown in the figure. The segment from A to B is frictionless, and the segment from B to C is rough, so there's going to be some friction over here. The point A is at height 9.7 meters, and the point C is at height 0.6 meters with respect to point B. Find the speed of the bead at B. The acceleration of gravity is 9.8. Well, at this point, at point A, I know that it can fall, so I've got some potential energy at point A. At point A, it's not moving, it starts from rest, so I know that my kinetic energy at A is going to be 0. At point B, since there's no friction, the energy is going to be the same. So at point B, I know that my potential energy at point B, if I ask myself, can it fall, the answer is no, because I'm at the bottom there and it can't go any further, plus my kinetic energy at B. So I know that my potential energy at A is going to be my kinetic energy at B. So I've got an mgh equals 1/2 mv squared. You'll notice that the masses also cancel out, so I don't need to know that it's 0.2 kilograms. So I've got gh equals 1/2 v squared. If I want the speed at that point, what I can do is multiply by 2, so I get 2gh equals v squared. So the v is going to be the square root of 2gh. So my velocity is going to be the square root of twice 9.8 times my height of 9.7. So that's going to be my velocity at point B. The next question says, if the bead comes to rest at C, find the change in mechanical energy due to friction as it moves from B to C. Well, since the energy at B was the same as the energy at A, which is what I showed up here, then I can say, well, what's my energy here at C? What's my energy here at A? And subtract the two. So I don't actually have to use this velocity and do 1/2 mv squared and pull in the mass. What I can do is find out that my potential energy here, some of it got lost when I came to this spot. So if I had my potential energy at A minus my potential energy at C, is going to be my change in TME, a change in total mechanical energy, which is asking how much energy lost to friction. So my potential energy at A is going to be mg, the height at A, minus the mg, the height at C. It's going to equal my change in TME. So this is going to be the mass of 0.2. I am going to need the mass now. Times gravity of 9.8 times the height of 9.7 minus my 0.2 times 9.8 times my height of 0.6. And that's going to equal my TME change. So now it's just math. Multiply those, subtract those. You also could be smart and see that 0.2 times 9.8 can factor out, and I get 0.2 times 9.8 times the difference in height. So it's going to be mg times the change in height is going to be how much energy was lost. But either way, you can get your total mechanical energy right there.